Alright, this is lesson 10, dividing polynomials using synthetic division. So last week we did those long division problems, right? Remember those? So there's actually, if you look at it, if you're ever looking at a long division problem, we're always organizing everything. And someone thought, well, if we're always organizing everything, what's really different on all the problems? Well, it's just the coefficients. So instead of writing out all of these like terms about x squared, or x to the fourth, x to the third, x squared, x to the first, someone just thought, well, instead of writing all that out, let's just use long division, or let's just use the coefficients to write everything out and to organize it, because those are really the important numbers. Okay, so we're going to be looking at this thing called synthetic division. It's kind of a shortcut. It doesn't work on all the problems that you are going to do for the test, but it works on some of the problems, okay? So the steps are on the board right here. Identify and write the coefficients of the dividend in descending order. Identify a and x minus a. Bring down the first coefficient, multiply this by a, add the next coefficient with the answer, repeat, and write the final answer with the proper variables. Okay, if you're in the video, you should pause so you can see this. Here we go, number 1. So number 1, whenever I'm noticing that I have a long division problem, and then if I look at my divisor and there's a coefficient of 1, a leading coefficient of 1x, not 5x but 1x, then I can use synthetic division. This is how you do it, so watch carefully. So you take the biggest exponent, here we have x to the fourth, and we ask yourself, what's the coefficient in front of x to the fourth? It's a 1. And then I take x to the third, the coefficient in front of here is negative 11. Then I take the next coefficient, positive 19. Next coefficient, negative 16. Next coefficient, positive 63. Okay? And that's it for that. Then I look at my divisor and I'm trying to identify what a is. A is like saying x minus a, so in this case a would be equal to 9. Not negative 9, but positive 9. So that's what our a is positive 9. So we're going to put this on the left, and then we're just going to put a little box around it so I know that's the divisor. Okay? Then we're going to draw a line like this, and you're going to be really amazed at how easy this is. Okay? So you take the first term, just bring it down. 1. Then we multiply. 1 times 9 is 9. So then I'm going to write the 9 right here on the next spot right here. So 1 times 9 is 9. Then we add negative 11 plus 9 is negative 2. Then we multiply negative 2 times 9 is negative 18. So we could write a negative 18 right there. Then we have 19 plus negative 18 is 1. 1 times 9 is 9. So we put a 9 here. Then we have negative 16 plus 9 is negative 7. Then we have negative 7 times 9 is negative 63. 63 plus negative 63 is 0. Okay, this last number would be your remainder. So then I would write my final answer. We wouldn't leave our answer like that because this is meaningless. We have to put meaning behind it. So we're just going to write it in descending order. I like starting with my remainder first. There is no remainder, so I'm going to start with my constant, which is negative 7. Then we have 1x. Instead of 1x, I'm just going to put x because there's the coefficient of 1 is assumed. Then we have negative 2x squared and positive 1x to the third. Okay? And you could see all I did was copied all those coefficients to the side right here. That's it. That's how you do number 1. A lot easier, right? So again, what did I do? I looked at my division problem. I noticed that the divisor has a coefficient of 1, so I could use synthetic division, because if I couldn't use, or if it wasn't 1, I couldn't use synthetic division. Then I took all my coefficients in descending order, starting with the largest exponent, x to the fourth. What's the coefficient here? 1. Next one, negative 11, 19, 16, 63. Okay? And then I found what my a was. A is always x minus a, so what is next to the minus sign? There's a 9 here. So we put a 9 here. Then we ask ourselves, first term we bring down, 1, bring it down here. 1 times 9 is 9. Combine, you get negative 2. Negative 2 times 9 is negative 18. Combine, you get 1. 1 times 9 is 9. Combine, you get negative 7. and so forth, remainder of 0. Then at the end I wrote my whole answer down in descending order, all organized, including all of the terms. And there should be a plus 1x here. Should have put a plus sign here. Right? So, that's how you do number 1. Let's watch it one more time. Number 2. On number 2, again, I'm noticing this is a long division problem, and the term here has a 1 at the beginning of it as the coefficient. So I'm starting with the largest exponent, which is 4. So we got, oh, this is the exact same problem. Okay. I messed that up. Alright, anyways. That's how you do number 1. We'll do a few right now. Questions on numbers 1 or 2? Or on number 1, really. Okay, so, alright, continuing, number 3. Okay, number 3. I'll start you up and then you'll finish it off. Okay, so largest exponent on number 3. Actually, before that, can we use synthetic division here? Yeah, we can, because the leading coefficient here is a 1. So, what's the largest exponential term here? What? 5x to the 4th, right? So we start with that first coefficient of 5. What's the next coefficient in descending order? 7. Next coefficient? 12. Next coefficient? And last coefficient? Good. What's a here? We're trying to find x minus a. Negative 1, right? Because this is really like saying x minus a negative 1, right? So our a is negative 1. Okay. I'll start you off here. I'll do one step. We draw a line across the paper like this underneath all our coefficients. Draw an arrow to start with. We got, just bring down the 5. Then we multiply. What's 5 times negative 1? Negative 5. Okay. Bring that here. Then we add. What's 7 plus negative 5? What? Positive 2. Okay. So I'm going to pause there. In case you didn't get it, we got 2 times negative 1 is negative 2. You're done, you get a positive 10 here. 10 times negative 1 is negative 10. 7. Negative 7. 0. This last number would be your remainder. There isn't a remainder, so we're just going to write in descending order. We have 7. We got plus 10x next to it. We got a plus 2x squared. And I'm doing it backwards so that I'm not missing any terms. 5x to the 3rd. Okay? That's your answer. Now, if there was a remainder, someone had a good question. What if there was a remainder? Then you would just add plus the remainder over the divisor, which over here is x minus, or x plus 1. But in this case, there is no remainder, so this is, we don't need to include the remainder. Okay? Next one, number 4. Ready, set, go. By yourselves. Again, we have, we can use synthetic division here. We have n plus 8, so our leading term here is a 1, so we're allowed to use synthetic division. Largest term is n to the 5th. Coefficient in front of n to the 5th is 1. Then we have a 13. Then we have a 46. Then we have a 51. And these are real nice because they're all already in order, right? 22 and negative 16. Right? And then what is our a here? Negative what? Negative 8. Okay? So, draw a line. Bring down the first one as a 1. 1 times negative 8 is negative 8. 5. Negative 46. Negative 48. 3. Negative 24. Negative 2. And 16. Remainder of 0, right? And then we're going to write down our final answer in descending order. Since n to the 5th is the largest term, we're going to take n to the 4th first. So we have 1n to the 4th plus 5n to the 3rd plus 6n squared plus 3n minus 2, all plus the remainder of 0. Since there's a remainder, it's redundant to write 1, so we're going to leave it like that. That's it. Does that make sense? Most of you had that right. A few of you didn't. Okay, let's do at least one more. Okay. Let's do number 6. We're just going to go straight to 6 because that one looks more fun. Okay, so on number 6, can we use long division or synthetic division on number 6? Yes or no? What's the leading coefficient? 4. I thought we needed only a 1. Is there another way to write this divisor? Isn't 4 plus v the same thing as v plus 4? Okay, so what is the leading coefficient a 1? Yes or no? Okay, good. Now what's the largest term in my dividend? V to the 4th. What's the coefficient in front of v to the 4th? 1. Okay, good. What's the v to the 3rd coefficient? 4. Good. What's the v squared coefficient? There is none, so what do we have to put there?
0.
A 0, right? We're going to put a placeholder there, right? What's v to the 1st? 2. What's v... Actually, what's the constant term? 13. Okay. What's a equal to? -4. Good. Okay, I'm going to have you start off here. Ready, set, go. So the first thing, bring down the first one, bring it down. 1 times -4 is -4. 0 times 1, or 0 times 4 is still 0. So we have a 0 here. 0 times -4 is still 0. We have a 2. 2 times -4 is negative. Yeah? 5. And this is my remainder. Okay? So v to the 4th was the largest, so I'm going to do v to the 3rd. 1v to the 3rd, which is v to the 3rd, plus 0v squared, plus 0v, plus 2, plus remainder of 5 over my divisor of v plus 4. Okay, that's a valid answer. That's totally legit. But, 0 of anything, it's all like, I have $0 million, right? Who cares, right? So let's make this look a little bit better. V to the 3rd plus our constant of 2 plus 5 over v to the 4th, or v plus 4. Okay? So that's how you do number 6, okay? Yes?
So if you just put 4 plus v, it doesn't matter.
It's what's descending order? What's the largest exponent there? Is it the constant of 4 or v to the 1st? Yeah, that's better. It's neater that way. Is it wrong to put 4 plus v? Not really, but let's stay neat. Okay, remember Friday we said all that stuff about place markers? Let's just say, what if I didn't put my place marker of 0 on this problem? So look up here. I'm going to redo number 6. Okay? Redoing number 6. Let's say on number 6 I was all like, okay, who cares about putting placeholders? 1v to the 4th plus 4v to the 3rd plus 2 plus 13. And then we have -4 here, right? 1, -4, 0, 0, 2, -8, 5. Okay? You looking up here? Didn't I just get the same numbers as before? Predict what could have happened if I... This is the correct way to do it. What could happen if I didn't put the placeholder? What would you do at this point? Or what could students do on accident? They think the 5 is a what? Not a remainder. And what else? That's a good answer. Well, let's look at this. We got, what's the largest exponent here? V to the 4th. So they'll put v to the 4th plus 0v to the 3rd plus 2v squared plus 5v. Is this the right answer? No. So, is it important to put a placeholder in? Yeah, of course, okay? Sometimes the placeholder makes a difference in the sense that it affects the numbers that are being used, okay? So this is the correct answer, number 5 right here. This is incorrect. This would be wrong, okay? So make sure you got that. All right, that concludes the lesson for today. What I'd like you to do is turn to your neighbor,